Reverend ladies and gentlemen, we are going to start right away. Please, if you can hear me, if you can hear me, say yes in the comment box. If you can hear me, say yes in the comment box so that we can continue. Can you hear me? Just say yes if you can. Okay, yes. Okay, I'm going to share a document that I believe you can see the document I've shared. So we're going into the business. Okay. Have about 15 about. So, and one may ask you define vector or unit vector. We know that a unit vector is a vector that has a magnitude equal to 1 and is used to specify direction. If capital letter A is a vector, the unit vector will be that's equal to A with the arrow divided by the magnitude of that vector. And one can also ask you, or you may be asked to define the dot product. And we know that dot product is also called a scalar product. And the dot product of two vectors is defined as A with the arrow dot capital letter B of A modulus of B cos theta. And it produces a scalar quantity. So scalar quantity. And you may also be asked to cross products. Another name for cross products is what we call the vector product. The cross product is the A cross B equal to of A modulus of B sine theta multiplied by the unit vector called N. So, question 2, if vector A is given at AXI plus AYJ plus AZK, and vector B is given as BXI plus BYJ plus BZK, we can now define what is the dot product. So, Using the distributive property, dot product a dot axi plus ayj plus azk in bracket dots bxi plus byj plus bzk. Remember, if you have something like this, if you want to multiply, taking the first term to multiply by all the terms in the bracket is really a way, because we are familiar with the some identities like I dot j gives dots. We know that. So we simply multiply the I, bxi, j, byj, ay, azk, bzk. And that is what you have in the next line. By the time you do this, we know that I dot I is 1, j dot j is 1, dot k is 1. And this will amount a dot b, that is a dot product, is equal to axy, that is the dot product. Then the cross product will also be the product of the Cartesian form using the matrix approach, ijk. And by the time you expand it, you have this expression. So looking at, if this vector, question 3, given that vector A is equal to 3i plus 2j minus k, and vector B is 2i minus 4j plus 5k, and vector C is given as minus I plus 6j plus 2k, we can find the resultant of the three vectors. We can find the resultant of the three vectors. I repeat, vector A is given as 3i plus 2j minus k. Vector B is given as 2i minus 4j plus 5k. And vector C is given as minus I plus 6j plus 2k. Find the resultant of the three vectors. And what is the resultant? The total, effective, was simply to add the three of them. So the resultant R is equal to vector A plus B plus C. So by the time you do that, you have Rx is equal to 3 plus 2 minus 1. Remember, the i's are the x, which you have for vector A will have 3, for vector B will have 2, for vector C you have minus 1. So for Rx, that is the resultant of the x, that is the i's, we'll have 3 plus 2 minus 1, which will give us 4. And then for the Ry are the j's. You have 2j, that is 2 plus minus 4 plus 6. We have 2 minus 4 plus 6, and that will give us 4. And then for the z, that is, we're talking about the k's, minus 1 plus 5 plus 2, and that will give us 6. So the total resultant becomes 4i plus 4j plus 6k. And what is the magnitude? If you are asked to find the magnitude, that is the modulus of that, square root of 4 plus 4, that is the 4i plus 4j plus 6. If you take the square root of this, it will give you root 68. And if you find the square root of 68, that will give you approximately 8.25. So if you are asked to differentiate, assuming you are given vector A equal to t square I plus 3tj, find differentiate, and that will be the A, the t. We know how to differentiate 2ti plus 3. We are differentiating with respect to t. So this would be 2t plus 3j. So question 4. What is the position vector? Vector that specifies the location of a particle relative to an origin. That is what we call the position vector. Position vector is a vector that specifies the location of a particle relative to an origin. And what is a velocity vector? The rate of change of position with time, or change of displacement with time. So if you have question 5, if you have the position vector r of t equal to xti plus ytj plus ztk, and you are asked to find the velocity, is to differentiate that with respect to t, which is equal to the x dt plus the y dt plus the z dt. And what will be the acceleration? The rate of change of velocity. Acceleration becomes the v dt, which is equal to second derivative of the position vector over the t square. Question 6. Given that the position vector is this, we can, if we want to, t raised to power, the position vector r equal to t raised to power 3i plus 2t squared j. If you are asked to find the velocity, the differentiate with respect to the r dt, and differentiating 3t raised to power 3 will be 3t squared, and 2t squared will be 4t. We know how to differentiate. And at t equal to 2, we now substitute the value of t. If t is 2, 2 square, because we have 3t squared, so we'll substitute the value of t squared, which is 4 times 3, that is 12. Well, that is what we have here. And t for 2, that is 2 times 4, that is 8. We now have 12i plus 8j. Then for acceleration, we are talking about the v dt. That is the rate of change of velocity with respect to time. So if you now differentiate 3t squared, that will now give us 6ti. If you differentiate 4t, it will give us 4. So at t equal to 2, we also substitute. That is 2 times 6, that will give us 12i, and 2 times, at this point, there is nothing to substitute because we have 4j. So this will be 12i plus 4j. I hope we are getting along. So, question 7. The first law, Newton's law of motion. Second law, Newton's second law of motion, and third law. The first law states that a body remains at rest or in uniform motion unless acted upon by an external force. We all know that. Newton's first law of motion. A body remains at rest or in uniform motion unless acted upon by external forces. Then the Newton's second law, force equal to the rate of change of momentum. I will know that F is equal to ma. Then the third law, Newton's third law of motion. For every action, there's an equal and opposite reaction. So, question 8. If we are asked to find the magnetic force F is equal to QVB. But if angle is involved, F now will be equal to QVB sine theta. We know that. But if angle is not involved, F will be equal to QVB. And then the centripetal force is equal to mv square over r. So if you now equate the centripetal force and the magnetic force, we can now solve for r. That is saying that QVB is equal to mv square over r. And r now will be equal to mv over qb. So given the values, we can substitute the mass of the electron and the charge of the electron. So this, we can determine the value of R. Then the momentum conservation in an isolated system. Momentum conservation in an isolated system, we know that action is equal to reaction, and that's we'll know. Then for work done, we have W equal to the integral from 0 to x kx dx, and W is equal to integral from 0 to x kx dx, and W is equal to half k. By integration, we have half kx squared. So if the values are given, we can substitute and you calculate the work done. We can also define the simple harmonic motion of a restoring force. We can also define the damping. This have been explained. Reduction in amplitude over time. Simple harmonic motion where restoring force is directly proportional to displacement. And resonance, the maximum amplitude at natural frequency. So this can be defined, and then the energy conservation is equal to half mv square equal to G capital M small m all over R. That is the case of escape velocity, and you can make V, the subject, to be V equal to the square root of 2gm all over R, where all parameters have their usual meaning. Then if you substitute, we can get the value of escape velocity because all these parameters are constants. They are all constants and they will always be provided. So these are the things you should get familiar with them, and it'll be good to go. So if there's any question, you can ask your questions. because it is getting late, and I wouldn't want to keep you here for a long time. So if you don't have any question, I will call it today. For the recap, unit vector, dot products, cross products. You should be able to calculate the dot products, cross products, given these values. Calculate the resultants of two or more vectors. What is another name for resultant? The total effective. You should be able to calculate the magnitudes. You should be able to differentiate vectors. The position vector, velocity vector. You are familiar with the differentiation given the values at t equal to so values. You'll be able to do that. First law, Newton's first law, second law, third law, magnetic force, momentum conservation, work done, simple harmonic motion, damping, resonance, escape velocity, and so on. So, I wish you guys good luck. If there's any question, I'm still waiting. But if there's none, ask your questions. Okay. Somebody's asking, how can I calculate energy conservation? How can you calculate energy conservation? We know that the kinetic energy is equal to, that is half mv square is equal to capital G m small m all over r square. That is, for escape velocity, you can always solve for v. You can always solve for v. Half mv square is equal to gm, that's capital Gm small m over r square. So you can make v the subject. That is saying that v is equal to square root of 2gm all over r. And all this uh, somebody's asked a question here. I am confused about QEIA. Don't understand that. QEIA. You can put that question across again. Okay. If there's no any other question, we'll end the stream. Thank you.